Hey guys, so we're going to be trying this new video lesson thing today. Let me know how you like it. I always like feedback, but we're just going to jump right in without too much to do about it. So goal number 3 is I can determine the domain and range of a continuous relation. We kind of talked about what that was last class. We're going to start out with some general reminders. Just as a reminder, domain is all possible x values. X values. And remember, half the battle is remembering that X goes with domain. So I always think of Disney XD, Disney XD. Range is all possible Y values. And I, once again, don't really have a good one for Y and R besides my Harry Potter reference you've all heard already. So Y goes with range. So if you can think of something that goes with Y and R, that would be really, really helpful. Oh, that's a spider on my dot cam. I am very unhappy right now. I'm going to move that off of my paper. Look at it go. That's horrifying. Okay. All right. So remember that domain, I always read from left to right because that's how my x-axis goes. And range, I always read from bottom to top because that's how my y-axis goes. So we're now going to talk about different types of relations. A discrete relation is a set of unconnected points. A continuous relation can be drawn without picking up my pencil. Another way to think about that is all points are connected. So we're going to work on domain and range again. So I'm going to start with my domain. Domain is my x values, as we talked about. So domain is my x values. I'm going to put my pencil on a point, and I'm going to connect it to my x-axis. I'm going to connect all of my points to the x-axis. This is what we did last class, so just a reminder. This one's nice and labeled for me. This is a 1. I skip 1, so this is a 2, but I don't have anything there. 3, 4, 5, and 6. And I'm just going to list them out from left to right. 1, 3, 4, 5, and 6. For my range, I know that's my y values, so I'm going to connect my points to the y-axis, which is over here. And remember, I go from bottom to top, so I'm going to connect this one. I'm going to connect this one, these two right here, and these two right here. So I see I have a point connected at 1, at 2, skip 3, 4, skip 5, and 6. So my range, if I'm reading from bottom to top, will be 1, 2, 4, and 6. Just a reminder that the other way I can do that is by listing out my points. So I see I have 1, 2, so this is point number 1, point number 2, 3, 4, 5, 6, 7 points. 1, 2, 3, 4, 5, 6, 7. And I'm just going to list them out. Point number 1 is 1, 1. Point number 2 over here, that is my x value is 3 because I always write my x value first. 3 and then my y value of 2. Point number 3 also has an x value of 3, which means it's not a function, but a y value of 6. 4 is at 0.44. That's convenient. 5 is at 0.56. 6 is at 0.64. And 7 is at 0.61. So if you like to list out your points, you can do that. Remember that my domain is going to be all of my x values. My range is going to be all of my y values. And if I list those out, I should get the exact same thing I got before. Okay, this was for a discrete relation. What could I do to these points to make them continuous, though? We talked about this yesterday. I can connect them all by not picking up my pencil, and this would give me a continuous relation because all points are connected. Actually, I'm just going to draw an arrow. All points are connected. Okay, so now if I'm thinking about this, before I listed out all of my different values, I just listed them out. Well, now if I'm thinking about this point right here, which I know is 1, 1, and this point right here, which I know is 1, 2, 3, 1, nope, sorry, 3, 2, is it just an x value of 1 and an x value of 3? Or do I have a line connecting them? I do have a line connecting them. That means that every single point along this line is part of it. So if I look right here, this is an x value of 2, right? That's going to be part of my line, but I also have all of the millions of fractions that are between. So no longer can I just list out my points. I'm going to have to say that it's on a spectrum between those two numbers because I need to include every single number. So I need to include every number between 1 and 3. Every number in the whole world. And to do that, we're going to use inequalities. But that's getting a little bit ahead of ourselves. So right now, I want you to pause this video. Take a second if you need to rewind, watch anything again. Make sure you understand these notes before you jump into the next one, and I'll meet you on the next video for example 1.